Okay, hi there. Welcome to chapter 1.2, Measuring and Constructing Segments. The essential question, how can you measure and construct a line segment? What you will learn in this chapter is to use the ruler postulate, copy segments and compare segments for congruence, use the segment addition postulate. Okay, so here we go. Okay, example 1 says, using the ruler postulate, measure the length of segment ST to the nearest tenth of a centimeter. Now, my measurement is going to be different than yours. So in order for you to do this, you should probably do it in your book. But this is the process for measuring a segment. It's pretty simple. All I have to do is go, and I'm going to do it electronically. So I get my ruler, and it says centimeter. So on this ruler, the bottom here is inches and the top is centimeters. So what you want to do is you want to move the ruler to one of the endpoints and call it S. How about S? So I start at S and put this right on that point there. And I measure over, this is 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, and it goes out to, it looks like about 4. So I'm going to call that approximately 5.4 centimeters. Okay, measure to the nearest tenth. Okay, 5.4 centimeters, 5, and then 1, 2, 3, 4 marks here. Those are 4/10. Centimeters are always, metric system is all in tens. It's very easy. There's 10 millimeters in a centimeter. There's 10 centimeters or 100 centimeters in a meter, and so on and so on. 1,000 meters in a kilometer, kilo meaning 1,000, kilometer, kilometer, 1,000 meters. And so anyway, 5.4 centimeters is the length of ST. And how I would write that would be, it looked like absolute value brackets, and I put ST equals. That just means the length of ST equals 5.4 centimeters. Okay, the other thing I need to do is put this over top. So segment, the length of segment ST equals 5.4 centimeters. Now, the way the book is asking you to do it or showing you how to do it is they just take the ruler and just line up any integer on S. I'll just do a different one than the book. And they put an integer, a whole centimeter mark on one of the ends. So S is 3. So the length of ST is going to equal, segment ST is going to equal the absolute value of your starting point 3 minus, so it's always the left minus the right. And the right here looks like to be 8.4. So then I put 8.4 over here and close my brackets. So ST, the length of ST is going to equal 3 minus 8.4. Okay. So if I take 3.0 minus 8.4, well, how do we subtract a bigger number from the other? Okay, so all you really do is take the bigger minus the smaller. And 4 minus 0 is 4, and 8 minus 3 is 5.4. But then you take the sign of the larger. And 8.4 was negative here. 3 minus 8.4 or plus a negative 8.4. So you take the sign of the larger, so that 5.4 would end up being negative. So this is going to come out to be negative 5.4. So the absolute value of negative 5.4, so therefore ST, segment ST, is going to equal the absolute value of negative 5.4, which is 5.4. Okay, and it comes out to be the same. And I'm going to say CN. Always use your unit of measurement at the end. Okay, so that's the way the book was showing it. Just taking any value. If you use 0, then the other end is going to be your answer. But if you didn't use 0, then we're using the distance formula, basically, and we'll get into that later. Okay, example 2, comparing segments for congruence. Congruent meaning same measurements, but maybe in a different location. They aren't equal. They aren't right on top of each other. They don't coincide, but they are congruent because they have the same length, different location. That's what congruent means. So the first thing I'm going to do is I'm going to switch to my highlighter. And I'm going to use blue. And it says to plot J, K, L, and M, these 4 points, in a coordinate plane. So I have a coordinate plane here. Then determine whether segment JK and LM are congruent. So I highlighted this because whenever you have a segment named, the endpoints form the name. So I know that J is one end of this segment and K is the other. So I want to compare these two and find the length between these two. Because if you're given 4 points, you're going to have 6 different, you can have up to 6 different segments with 4 points. Okay, so if I had 4 points, here's one segment, here's a second segment, here's a third segment, here's a fourth segment, here's a fifth segment, and here's 6th segment. So with 4 points, I can create 6 segments, but they're specifically telling us which segments, where segments are located by the endpoints. So I can only get 2 segments when they tell us the name of the segment, if that makes sense. Okay, so JK is the endpoints J and K. And then let me switch back to my highlighter and I will use green. And this name of the segment is LM. So here's L and here's M. Those are our endpoints of the segment. So we're going to find the length between these two and the length between these two. Switch back to my pen. I will use blue for JK so it matches. So I'm going to say the length of JK. So JK equals the absolute value of one end. Well, actually, let's plot them first. It says plot them. So plotting J, which is -3, 4, would mean to go over 3 from the origin. You start at 0. The X value is left, right, and -3 means to go to -3. And then 4 means to go up to 4. So the 0.34, which is right here, is where J is located. And then K is right 2, up 4. So K is right here. I will connect those. So I'm going to draw a segment from J to K. So there's segment JK. So we plotted that one. Now I'm going to switch to green. I'm going to plot the point 1, 3. So that means go right 1, up 3. So here is 1, 3, and that is point L. M is over to the right 1 and down 2. Right 1, down 2 is right here, and that is M. Then I switch to my segment. If you're doing this on paper, obviously you would use a ruler. This just draws me straight lines, so I don't have to use the ruler. I could. There is an electronic ruler here, but I'm just going to do it this way. Okay, so there's LM. So there's JK and there's LM. Now we want to determine if they are congruent. So that's the key word to this question. So I'm going to highlight that. What are they asking us? Determine, try a different color, determine whether they are congruent. Okay, so in order to find the length of something, we use the postulate. So we're going to use the ruler postulate, if you will, and that's really the distance formula. So what you do is you take one endpoint and you subtract the other. So J, the X value is negative. Switch back to my blue. J is at -3 and K is to the right at 2. And the horizontal distance is the same, so we can ignore the Y's, okay, because they're equal. We'll get into that later. So if we just do a horizontal distance, we want to find the difference between the X values when it's horizontal. So I'm going to take the difference of -3 minus 2. So JK is going to equal the absolute value of -3 minus 2, which is -5. And the absolute value of -5 is 5. Now, what if we did it the other way? What if I said, well, let JK equal the distance between the right end, 2, and I'm going to subtract the left end, and that's careful, minus a -3. And so then, therefore, if we did it this way, we'd get the absolute value of 2 minus a negative 3, which is 2 plus 3, and that's going to give us a positive 5 in the absolute value bracket. Well, the absolute value of 5 is still 5. So as you can see, it does not matter which ends you put first or second. You're going to get the same value. One will be negative in the absolute value bracket, one will be positive, but when you take the absolute value, you'll get the same number on the number line, if you will, the absolute same distance from 0. Negative 5 is 5 from 0, 5 is 5 from 0. So the order does not matter for endpoints when you're determining distance. Now we're going to see how long LM is. So L is at 3 on the Y, and M is at negative 2 on the Y. And the X's are the same, so I'm going to ignore the X's. So I'm going to say LM equals the absolute value of one end minus the absolute value of the other end. And be careful, it's minus the negative 2. If you forget that negative sign, you're going to get an answer that's not correct. So LM is going to equal the absolute value of 3, and a minus a negative means plus, so 3 plus 2, 3 plus 2, I'll show that here. And then we're going to get LM to equal the absolute value of 5. So LM equals 5. Okay, so JK equaled 5 and LM equals 5. So therefore, I will now say, now let me keep the colors. I'm going to say JK is congruent to LM. Okay, and I don't want to forget that they are segments, so I want to say segment JK, segment LM are congruent. Now, when you don't use the segment line over the top of the letters and you're using the two, that just simply means the length of. As soon as you put that over there, you're saying segment JK. Here we're saying the length of LM, the length of JK, because there is no line over top telling us that it's a segment. So when you don't use that line over top, you say the length of JK equals. Here we're saying segment JK is congruent to segment LM. Okay, so we're going to lead up to the segment addition postulate here for the next example, but before I do that, I want to explain something first. So it says when 3 points are collinear. Collinear, remember, means that the 3 points would be on the same straight line. Then you can say that 1 point has to be between the other 2. So there are 2 examples here, an example and a counter example. So in this example here, B, A, and C are collinear. They're all on this line AC or line AB or line BC or line CB or line CA. You can name any 2 points on a line, any order would name a line. Point B, therefore, is between C and A. It's in between them. Okay, think of 3 people in a line, the first person and the last person, and then someone in between them. So A is first, B is in between C and A because C is last. Okay, A is first, C is last, B is in between them. Collinear, straight line. But in this situation, E is not on the same line. Here is the line DF or line FD, and E is not on it. We cannot say E is between D and F. E is off to one side. We would have to form a triangle now to connect all 3. Or it would be an angle. So if this DF line was not here, we'd have to draw a line from D to E and then E to F, and it's not a straight line. So E is not between D and F. So in order to use segment addition postulate, we have to have what's called betweenness. Okay. Okay, so here is the postulate. If you do have betweenness, then this postulate works. And it says segment addition postulate. That's the name of it, postulate 1.2. And it says if B is between A and C, okay, so let's follow this. My pen's in my hand, but it's upside down. Okay, here we go. So if B is between A and C, so here is B, A's here, C's here, B is definitely in between them. Then we have smaller segments. We can call the distance from A to B, segment AB, that's right here. And then we can call the other piece from B to C, segment BC. Okay, so when we add these two up, we would say AB plus BC equals, and you ignore the point that's in the middle, and the new name is the whole thing, AC. See where that comes from right there? All right. So in this situation here, AB plus BC equals AC. And it says if AB plus BC equals AC, then B is between A and C. So that is the addition postulate, and that's what we'll be using for example 3. Okay, so give me a moment. Okay, so this is going to be the first time I give my mathematical rule, and it applies to all classes. Math 6, Math 7, Math 8, Algebra 1, Geometry, Algebra 2, Pre-Calculus, Calculus. Always do these 4 steps right here when solving a problem. Number 1 is write the formula. 2, substitute the givens. 3, simplify and solve. And 4, always at the end, ask yourself, does my answer make sense? And if it doesn't, especially in word problems, go back and make some changes. Don't just say, oh, I got an answer, I'm done. All right, so here we go. We're going to find DF. So we're going to use the segment addition postulate. And A says find the length of DF. So whenever you have a segment and there's no bar over the top, you say the length of. Find the length of DF. So here is DF. E is between D and F. So step 1, write the formula. So I'm going to write the whole thing. I'm going to write the formula. I'm going to say DF equals DE, okay, DE plus EF. So there's my formula. That's step 1. Write a formula. Don't always just jump in and put it. I want you to learn these. I hate to say memorize, but to be able to picture a diagram in your head and put an equation together or a formula together, rather than calling it memorization, you're recalling the process of what developed it in the first place. So I'm going to say DF equals DE plus EF. Then I substitute my givens. Well, I don't know what DF is, so that's staying DF. And then I look at DE, and it is 23. And then I hit plus, and then EF is 35. So I substituted in my givens. That's step 2. So I wrote the formula, I substituted my givens. Now I want to simplify and solve. That's where I am now. So step 3, I'm going to say DF equals 23 plus 35. Well, 3 plus 5 is 8, nothing to carry. 2 plus 3 is 5. So DF equals 58. And then ask yourself, does my answer make sense? Self, does my answer make sense? And I look, and each piece is 23 and 35, and my total obviously should be more than those two. Actually, it's the sum of those two. And yes, my answer does make sense. So the length of DF is 58. All right, so let's do this again. Now that was A. So now we're going to find B. Now I'll use red for B. So here's B. So I'm not going to write the numbers 1, 2, 3, but I'm just showing you that's what we're doing. We're going through all these steps, and I never checked the other two. So anyway, 1, write the formula. And we have a segment that goes from F all the way to H. So I'm going to say FH, the whole thing, equals the left end going to the point that's between, G is between F and H. I'm going to call this FG plus GH. So it's FG plus GH. Then I'm going to substitute the givens. Here's where we are now. I don't know the length of the whole thing. FG is 21. Actually, I do know the length of the whole thing. My fault. I didn't even look up there. They gave us the length of the whole thing. It says the FH is 36. It says find GH. So when you write a formula like I'm asking you to, and you substitute the givens, you're always going to solve for the unknown. And so now it's FH, which is 36. So I'm substituting my given here. Now I have 36 equals, and FG is 21, and GH, I don't know. So I'm going to leave that GH. Okay, and see how that just falls into place here? And now we're just going to solve this just like we did in Algebra 1, thinking of GH as just a variable X. 21 plus X, how do you get rid of that 21? How do you solve for X? It's the subtraction property of equality, which means subtract 21 from both sides. You want to isolate your unknown. So 21 minus 21 is 0, and that leaves me with GH, because 0 plus GH is GH, equals, and 6 minus 1 is 5, and 3 minus 2 is 1. So therefore, GH is 15. So the length from G to H is 15. Okay, so I simplified and solved. And does my answer make sense? Is 15 less than the whole thing? That's the one thing that you want to look at. If the whole thing's 36, your pieces better be smaller. And 15 is less than 36, and that makes sense. And if I take 15 plus 21, I get 36. So that's a way of checking. Okay, so there is the segment addition postulate. Okay, example 4 is a real world situation of the between this and the segment addition postulate. So let's see, I guess I'll use, what color? I guess I'll use blue. Blue's not used in any of this. So this is a map of the United States, and this little red square is showing where this is zoomed into. Okay, we're right in the smack dab in the middle of the country, and Lubbock, Texas, Tulsa, Oklahoma, and St. Louis, Missouri. Okay, and we are told that the distance from Lubbock, Texas to St. Louis is 738 miles, and the distance from Lubbock to Tulsa is 377 miles. And it says the cities shown on the map lie approximately, so it's an approximation, they lie approximately in a straight line. So if they're in a straight line, then T is between L and S. So if it's a straight line and you have 3 points, they're collinear. The point in the center in between the two is going to create 2 segments that add up to the whole. So it says find the distance from Tulsa, T, to St. Louis, Missouri. So what we're trying to find is TS. Okay, so it says from Tulsa to St. Louis, Missouri. So the segment TS. So that's how I start this. I'm going to write the formula. Step 1, write the formula. ST or TS. Doesn't matter what I call it. Let's stay with TS. TS, the length of TS equals. Well, then I look at that, I'm like, oh, wait a second, that's a segment. So that's not right. What is the whole thing? So the segment addition postulate says take the entire segment, which is LS. So I'll call that LS. The length of LS equals LT. So I'm talking about this piece right here, LT, plus the distance from Tulsa to St. Louis is TS. Notice the middle letters are equal, and if you get rid of them, you get LS, and that's the name of the whole thing. So LS equals LT plus TS. Write the formula. Step 2, substitute the givens. Well, LS is the whole thing, and that is given 738 miles equals LT is given 377 miles plus TS, we don't know. I'm going to write TS and then MI next to it for the miles. So we have the whole thing equals the Lubbock to Texas distance plus the Lubbock to Tulsa distance plus the Tulsa to St. Louis distance. So there's our formula. Write the formula, substitute the given, simplify. We're trying to solve for TS, the distance from Tulsa to St. Louis. So the subtraction postulate of equality says to subtract 377 miles from both sides. These cancel. 0 plus TS would be TS MI, if you will, equals, and 8, we have miles over here. So I guess I don't need TS miles. The length of TS in miles is what that would mean. That's okay. Is 8 minus 7, which is 1. 3 minus 7 I can't do, so I'm going to borrow 10 from there. 13 minus 7 is 6, and 6 minus 3 is 3. So the distance from Tulsa to St. Louis is 361 miles. Okay. One thing I didn't mention is number 4, does my answer make sense in the context of the problem? So if I have LS, which is 738, so now I'm going to check it. How about, that's one way we can determine whether our answer makes sense. Does LS actually equal LT plus TS? Well, LS I got as LS is the whole thing, 738 equals LT, which is 377, plus TS, which we got to be 361. So does 738 equal the sum of these? Well, then you just add them. 7 plus 1, 8. 7 plus 6, 13. Carry the 1. 3 plus 3 is 6. Plus 1 is 7. 738 equals 738. My answer checks. I made sure my answer made sense in the context of the problem. Okay, that's the end of lesson 1.2, chapter 1.2. Now go do your exercises, problem numbers listed here.